Okay, so the next thing I'm going to talk about is about differentiation and integration. Okay, in FEM particularly, whenever you are talking about element matrices, uh, what will you encounter when you have to evaluate entries of a element stiffness matrix? Entries of a element stiffness matrix, what will you encounter? What kind of mathematical operations do you come across when you have to evaluate the element stiffness matrix?
Integration.
You have to do integration. Integration over what domain?
0 to L.
That is in 1D. No, not 0 to L. In FEM, it is over element domain.
0 to 1.
So, in FEM, it was XC to XC plus 1 in 1D. But anyhow, it has to be integration over element domain. And as far as integrand is concerned, what do you have in the integrand? You have some derivatives. Okay, so in 1D we had something like deep psi ei by dx and so on. So now let us see as to how do you do integration and differentiation in Mathematica. So let us say we will use what we have defined in the last class. So let us say you have a function called psi, let's say psi1 as equal to x bar square or x bar cube, just for okay, just so that this is realistic, let me say that this is x bar minus half or x bar minus 1/3 into x bar minus 2/3 into x bar minus 1. How many nodes am I considering within the element?
4.
I'm considering 4 nodes. Very good. So what are the node points? X bar equal to 0, 1 by 3, 2 by 3 and 1. Now what will be the constant factor here if this was an interpolation function for local node 1? 1 by 3, 2 by 3, 1. What do we call this? So this is a polynomial expression in x bar. What do we call these numbers? 1 by 3, 2 by 3. These are called the roots of the polynomial. So these are the points at which the interpolation function has value 0. Now at x bar equal to 0, what should the function value be? For psi e1, what should be the function value at x bar equal to 0?
Divide by whatever the value is at x bar equal to 0.
So what will that be? So in this case it will be minus 2
minus
by 2 by 9. So I have to multiply it with minus 9 by 2. Okay, I have to do multiplication by minus 9 by 2. Once again, remember that there is no multiplication symbol really. Multiplication is implicit. Alright, so we have defined this function psi1. Now let us say I am interested in finding out the second derivative of psi1. Okay, so in order to do second derivative of psi1, let me say I'll represent it with d2 psi1. That will be the second derivative of psi1. So first thing is, for differentiation the symbol is capital D, simple. Okay, so capital D, square bracket open, square bracket closed. Now what do you want to differentiate? You want to differentiate psi1. With respect to what variable do you want to differentiate? You want to differentiate it with respect to x. How many times do you want to differentiate? You want to differentiate 2 times. So this is the syntax for x bar. This is the syntax for differentiating a function with respect to some variable a certain number of times. Okay, now you can do the differentiation manually. Okay, so when you differentiate it the first time, Okay, this is a little, okay, let's differentiate it 3 times. Then the answer is easy. So what will it be? If you differentiate it 3 times, you are going to get, what was the coefficient of x bar cubed to begin with? It was minus 9 by 2, correct? Now x bar, if I differentiate it 3 times, what do I get? 3 into 2, which is 6. So 6 into minus 9 by 2, which will be 3 into 9 or 27. So here I got the answer of 27 if I differentiate it. If I differentiate it 3 times. If I differentiate it once, then what will I get? If I differentiate it once, okay, it is a little expanded. I can say simplify. Okay, I get this. You can evaluate it. Okay, you can evaluate that this is indeed true. So this is how you do the differentiation. Okay, now let us say I had a function of 2 variables. Okay, instead of just x bar, let us say I had x bar times y bar plus x bar square plus y bar square, some function, doesn't matter really. Okay, now let us say I want to differentiate it with respect to x bar. Okay, 2 times. Even now I can do this. Okay, then I get it 2. If I differentiate it with respect to x bar once, then I would get 2 times x bar. So differentiating it once gives me 2 times x bar plus y bar. Okay, now if I want to differentiate it once with respect to x bar and once with respect to y bar. Okay, so I am doing d square psi 1 by dx bar dy bar. So then this is how you would write it. Okay, no, maybe this is not the just. Okay, so this will be the syntax if you want to differentiate it first with respect to x bar, then with respect to y bar. Okay, so yeah, only this term survives really when you do the differentiation both with respect to x bar and y bar. Okay, so this is how you carry out the differentiation. Okay, now let us say you are interested in doing integration. Okay, then instead of d you use the word integrate. Okay, now when you are integrating you can either integrate it without any range, or you could integrate it with some range. Okay, so let us say I want to integrate x bar from 0 to 1 and y bar from 0 to 1. Okay, then this is the value of the integral if I am going to integrate it from x bar with respect to x bar and y bar once. How do I know this is correct? Well, you can go ahead and then evaluate it. It's not a very difficult integral to be evaluated. Okay, so this is how you can go ahead and do the integration. So